All right, class, so where we left off was percent yield, and that is a way for chemists to compare actual to theoretical. Remember, your theoretical being the maximum amount that could be obtained, okay? The actual being what you actually produced in a lab, okay? Theoretical being the maximum amount. We want to get closest to that as possible because then a chemist is going to be doing a good job. Okay, if you're producing the maximum amount of product you theoretically could, that's a great job. Okay, but that's not realistically going to happen. You're always going to be a little bit less than 100% because our equipment isn't perfect and we're not perfect. So what we need to do is we need to be able to figure out how good of a job we did by analyzing that. And like in this problem, it's not in your notes or it's not in your homework or anything. I just wanted to give it as an example. We are comparing the theoretical amount, which is what we theoretically calculate in an experiment. This is the maximum amount that we could produce, and we're going to compare that to the actual amount that was produced. Now this is a measurement we get in a lab, sometimes in a problem it's given to us. So we take our actual over our theoretical times 100, and I get a percent yield. And this tells me, again, how good of a job I did at my experiment. The closer to 100, the better. Now, in your homework, worksheet 1.7, there's a little different take on it in that I'm not always comparing actual to theoretical. In this case, I'm calculating how many grams are produced. So I'm calculating my actual, given my percent yield. So what I did was I calculated my theoretical here, and I remember my equation, my percent yield equation says actual over theoretical times 100 gives me my percent yield. Now in this case, I'm given the percent yield. I calculated theoretical. I'm trying to find the actual. So I just rearrange this equation, multiply by 35.46, divide by 100, and I get my actual amount of iron that must have been produced if that was my percent yield. So hopefully that helps you with the back of worksheet 1.7 and finishing that and understanding the other percent yield problems. For today's homework, remember, finish worksheet 1.7. I didn't give you 1.8 in class, but I will give you that, and you can use this video to help you with the molecular pictures problems. There's 3 of them. We're going to do one of them together. Remember to finish your review assignment for Thursday. Try learning target 17. It's a tough one, but go ahead and try it, and skip 18. Okay? Also, your review and stations activity is due on Monday. All right, so this is for your molecular pictures worksheet 1.8. In this, what we need to do is be able to interpret graphical data and understand how it's representing a chemical equation. For example, in this equation, we have our reactants and it's going to produce products. So what we need to do is identify what the limiting and the excess reagents are based on our drawings. So our drawings show a graphical interpretation of nitrogen monoxide and oxygen, with nitrogen monoxide being a square and a circle here, and the oxygens being represented with the 2 circles. So what I'm going to do is just draw my products and cross out whatever reactants I use. So I'm going to go ahead and draw as many nitrogen dioxides as possible. So once I do that, notice that uses 1 square and 2 circles. So I cross out 1 square and 2 circles on my left side. I do it again, I cross out 1 square and 2 circles on my left side. I do it again, I cross out 1 square and 2 circles on my left side. I do it again, I cross out 1 square and 2 circles on my left side. Now notice I'm out of squares, so I can't produce any more nitrogen dioxide. So all that must be left is these oxygens, these leftover oxygens. So that tells me that my excess reagent, because I have leftovers, is oxygen, and my limiting reagent is nitrogen monoxide. Now on my homework, here's a quick problem, number 2A. Here we're working a little bit backwards in the fact we're given products, and I'm asking for you to calculate reactants. So I'm given my products, and I'm going to go back and calculate reactants. Well, if I'm given the products, I can right away determine who the limiting reactant and the excess reactant are based off of who I have left. So if I look, I can see here H2S, H is a square, S is a triangle, so 2 squares and a triangle. I have leftover H2S right here. I don't see any leftover oxygens by themselves, so I'm going to go ahead and say H2S is my excess, oxygen must be my limiting. Now I'm going to work backwards again, making as many reactants as possible. So I'm going to make an H2S, I'm going to cross out a triangle and two squares, I'm going to make another H2S, I'm going to cross out a triangle and two squares, make another H2S, cross out a triangle and two squares, make another H2S, cross out a triangle and two squares, another H2S, cross out a triangle and two squares, and voila, all I have left is oxygen. So I'm going to make as many oxygens as I can, and then that's a proper representation of my chemical reaction using symbols. Okay, so today's goal was to get better at percent yield and interpret and describe reactions using symbols. So hopefully that helped.